So our first speaker this morning is Woody Sullivan, who is obviously famous in many ways. Of course, we try to focus on authors. So his, of course, is Cosmic Joy, the history of early radio astronomy, that he thought was his most important thing to let people make their own choices. So he'll tell us what happened.
Good morning. So we thought it'd be a good idea to, what really did happen at Project Ozma. And of course, you might say, well, Frank is the ideal person to do this. And in fact, he did it 25 years ago when we had the conference. Perhaps I can give a little broader view than Frank's story. And I encourage you to read his article in the proceedings from 25 years ago. I also apologize to about 6, 7, 8 of you who were at Frank's 60th birthday party in Boston 10 years ago, or 70th birthday 10 years ago. And that it's about half the same as that talk. So first, some cultural context. This is 1960, what was going on? Kennedy was running for president, a Catholic. That was the big issue. But there has been some progress in this country. We forget that sometimes, and this is another thing, smoking was cool. Here's the head of R.J. Reynolds, surrounded by thousands of cigarettes. 59 Chevy, that was the ultimate in strangeness and stupidity. I think we've come a little way since then, too.
My first car.
Some decent movies came out that year. Ben-Hur, Psycho, Wild Strawberries, and so forth. Unfortunately, Seth Shostak is not here. It's my homage on Seth. If you're listening to this, we would entertain you with all the lyrics which are in our core memory on Itsy Bitsy Teeny Weeny Yellow Polka Dot Bikini and Poison Ivy and La Bamba and so forth. Up here in the world, you had serious things going on as always, of course. U-2 spy pilot shot down over the Soviet Union was a very big deal, to say the least. Francis Gary Powers, and of course then the U-2s were flying over Cuba shortly after Kennedy was elected. This is the context in which Frank Drake was operating at Green Bay. And here's the quiet, peaceful Deer Creek Valley. You can see the 85-foot dish and then the 300-foot dish that was built 2 years after Project Ozma. Before the 85-foot dish, there was really nothing much up here. This was one thing that came in more or less simultaneously, a 100-foot long horn that was John Finley's baby that was banked so that it would see Cas A as it came by every day, as a calibration device and as a standard, and get that flux exactly right. Turns out that Cas A was declining 1% a year, which this horn and several others were the ones that discovered in the early 60s. And here is an almost contemporary photo of Frank a couple years after Project Ozma with the new 300-foot in the back. It lasted for 26 years, as we know, and then had an untimely end. But we're going to focus on the 85-foot dish, and it's delightful. It was named after Howard Tatel, an engineer who was working at the Carnegie DTM, who had died during the process of designing it. And his son, David Tatel, has been here at the conference, and it's delightful that he's here. Why this 85-foot? Because the 140-foot was a disaster in terms of it took forever to get it designed right. In particular, that huge yoke that you saw turned out to be made of steel that would become brittle in the cold. And this was a huge screw-up. They got it down here and they realized it was made of the wrong kind of steel. And apparently it's buried here. It was just too much trouble to cut up and take away. And so rest in peace. But that delayed things by many years. And so in the interim, NRAO was around without a big dish at all. They were able to order this off the shelf and from Blau Knox, and it came within a year. That's why it came. Here's the timeline for the beginning. Green Bank out here began in '57. Frank Drake got his PhD shortly after at Harvard, working on a hydrogen line in stellar clusters. He started NRAO immediately, joined John Finley and Dave Heachin. The project director was a person you probably don't know, Richard Emerson, who was from the AUI. I think he was ionosphere background, is that right, Frank?
Yes.
Yeah. 85-foot dish was dedicated in 1958. The head of NSF at that time, Alan Waterman, came out as part of the dedication. This was a big deal to have this national facility. First observations were 4 months after that dedication. And then within a year, you were beginning to get development of three different frequencies. And in particular, the work began on the receiver that would be used for Project Ozma. But notice that it's also a receiver that's going to be used for another purpose, for Zeeman splitting, for the 21 centimeter hydrogen line, which was a hot topic at that time to measure the magnetic field in the interstellar medium towards Cas A. And that will be a theme that will come up shortly. Just to give you an idea of the data that Frank was working on at that time, this was a drift curve through the galactic center, and you can see that it was not just a single Sagittarius A. That with, a 36 arc minute half hour beam, you had structure, you had other things going on at the galactic center, and this was a big result at the time to make this kind of map of the galactic center. Before, you just didn't have this kind of detail at all. And of course, the high frequency was one of the things that helped. Frank was also the first to detect Saturn in the microwaves at that time. But we all know that from childhood, really, and then from young adulthood and so forth, he was always very interested in the idea of extraterrestrials, and worked out by the time of being a graduate student that, in fact, taking a most powerful radar at that time, which was from a dish at Millstone Hill in the Boston area, 1 megawatt transmitter, it could be detected by us from 10 light years away. And there were stars that were 10 light years away. That was the motivation. And we had no idea whether all the stars might be populated such that even looking at a couple nearby ones, that you might pick them up. And here are a couple of the quotations that give you an idea of the thinking at that time. This is an article written contemporaneously almost with Project Ozma and Sky and Telescope that described the project and the equipment and so forth. Notice, I've forgotten this, Frank, that you had the idea of looking at unidentified radio sources whose celestial positions are close to those of nearby stars, because who knows, it might not really just be a continuum radio source, it might be ETI. But you never did that, I don't think. This is a diagram that looks very familiar to those of us in the SETI game for the last many decades, which originated here, but it's not really the same water hole at all. It does come to the same conclusion that you don't want to look at the low frequencies because of the galactic background noise, but this is not the quantum thing that we're used to seeing. This is the Earth's atmosphere, which of course is only relevant if you're looking from the surface of the planet. But nevertheless, it is that kind of a thinking that is the place to look. But that was not really the reason. This is kind of post hoc reasoning that 21 centimeters was used. And it was not magic frequencies, that kind of reasoning. The reasoning was you want to avoid criticism for making a receiver and putting all that money into it for something as perhaps frivolous as people would look at it, to look for ETI. And so the 21 centimeter line was being studied for Zeeman splitting, and you needed, for the Zeeman experiment, you needed good frequency stability, you needed narrow band, and so forth at 21 centimeters. So good, we'll look at 21 centimeters. So you mustn't think that that kind of reasoning was full up there. And in fact, in Cocconi and Morrison's article, likewise, they don't talk about this being a special frequency that we would all agree upon. What they talk about is that anybody that has radio astronomy is going to do 21 centimeter radio astronomy. And so they would have equipment at that kind of frequency. And therefore, that kind of points to that. It's not the later kind of reasoning that came on. Here's the block diagram as it was published in Sky and Telescope and also in Physics Today. I'll just point out a couple things. You had a state-of-the-art parametric amplifier, then called a reactance amplifier, 350 Kelvin system temperature, which is about 4 or 5 times better than you could do with standard crystal receivers at that time with this frequency. Beam switching, 2 horns at the front, so he's beam switching at 5 times a second. But he's also doing something called a DC comparison radiometer, which is a switching between a 100 hertz channel, that's his main frequency resolution, and a 1000 hertz channel. So you're switching between a narrow channel and a broader channel in order to take care of DC offsets. That was a standard technique at that time. So he's got double switching going on here. And this switch generator here is controlling it all. You've got a very high frequency stability. You've got 4 step downs in frequency in order to get down to this narrow bandwidth. What else do I want to say here? You're looking, of course, at the hydrogen line. You're centering on the radial velocity of the star. You know that. And you're tuning in frequency. So all of this stuff up in the top center is a high-quality ham receiver that allowed you to, a motor-driven tuner that went across at 1 hertz per second. And thus you got across your 100 hertz bandwidth in about 100 seconds. And so that was the effective integration time of 100 seconds. Here's the actual equipment. At the top there is the tunable shortwave receiver. A couple of very interesting things to point out. Strip chart recorder. Many of you never probably laid eyes on one of these, but that was the standard thing. Ink trace coming out 100 feet per day. Now, what was the analysis of Project Ozma? It was visually scanning the 100 feet of strip chart recordings every day to see if you saw any suspicious bumps as you tuned in frequency. And Frank told me last night, I've never asked him this question before, but he did not find any bump that he deemed suspicious enough to follow up on, which is kind of interesting after 5 weeks of looking through hundreds and hundreds of feet of strip chart recorders. But from the beginning, they also had a tape recorder there, reel-to-reel tape recorder, and a speaker. So radio astronomers do that kind of thing, despite how we always have to talk out against the movie Contact that, no, that's not how radio astronomy is done. He did not have earphones on, I think. Did you ever put earphones on? Right. So they were ready from the beginning. So back to our timeline. While this receiver is being built and they're getting ready for this project, in September '59, copy of Nature gets to Green Bank, Cocconi and Morrison, completely out of the blue as far as they're concerned. Cocconi and Morrison say, you should work at 21 centimeters, it's a great idea, Nature has put its blessing on it, and Frank is delighted. Hey, we're at 21 centimeters, and it's more legitimate than we thought before, and wow. The new director of NRAO, who had just arrived in July, Otto Struve, the great optical astronomer, who kind of strangely became the first director of NRAO, but that's another whole story. He was aghast because he was much more wiser about the way of things. Hey, they've stolen our thunder. We've got to get out. That this project has already been going, and you know, the new NRAO, you know, we own this project. And so he had been asked to give the Compton lectures at MIT, a prestigious lecture series, that autumn. And so in November, he spills the beans that, hey, Cocconi and Morrison is a great idea, and we've been working on it, and we're going to start observations soon. Well, that, of course, led to a media storm. I'll show you a cover of Newsweek in a bit. And that led to problems. And then Frank came out with this article in Sky and Telescope even before the observations had started. And you can see that's 3 or 4 months before the observations here. Here is that cover of New Week. The search begins, life in outer space. This was just one of many articles at that time. What were the targets? The 2 nearest sun-like stars, which turned out to be Tau Ceti. I laid my eyeballs on it. I can report to you I saw no flashes from Tau Ceti. And Epsilon Eridani. These stars were not out of the blue. They had been previously mentioned by Otto Struve and Suju Wang and Cocconi and Morrison in their article had pointed to these. They're not solar-like as we would talk about today. They're G8 and K2, so they're lower mass stars and cooler than the sun. But nevertheless, they were the most solar-like of ones within 20, 30 light years. Epsilon Eridani now is known to have a super Jupiter planet. And here is the actual first day of observing, 11th April 1960. Receiver, they call it the OZMA receiver. There you see FDD is the observer. First thing Tau Ceti here, you can't really read Epsilon Eridani. And then over to Wolf 359, which is one of the 2 control stars that they were using. And so after the first week of observing, great excitement, I'll describe that, the parent breaks. The receiver front end broke, which is a very touchy thing. It took an hour to tune up with 4 micrometer screws, all these cavities that you had. It was very, very finicky and very difficult to operate, but once you got it operated, it was beautiful. And so they had to have an interim of about a month doing nothing, 5 or 6 weeks actually, and then they had another month. So the total observing time was about 5 weeks. And this kind of summarizes what happens. Over that time, there were about 200 hours of data, and as I mentioned, never did they see something worth following up. Now, most of you are familiar with the story that, however, the first time that they went on Epsilon Eridani, the second star, almost within a few minutes, all of a sudden, pulses came in. 8 times a second kind of stuff. And they just were beside themselves. Could it be this easy, that you just look at a new star and there it is. And Frank went running around. He was convinced that, something in the equipment and so forth. They never thought about, well, let's just take the dish off and see if we're still getting And so they didn't take the dish off, and after a few minutes it stopped. Now they don't know what's going on. And so they went back and spent more time at Epsilon Eridani over the next week until finally it did stop. It came back. And now they took the dish off and it was still there. But also they had a horn now stuck out the window as a monitor for interference. And that was getting it also. And so this was some kind of military radar or something. But that was the only false alarm in the entire project. So coverage for each star, 360 kilohertz. That was to take care of Doppler shifts of an orbiting planet, 75 kilometers per second. And so that's now defined as 1.0 OZMAs. That amount of integration, that amount of sensitivity. And I haven't had a chance to ask Dan, where's Dan? So how many OZMAs?
I think it's 10 to the 14 osmos per second or something now.
10 to the 14th osmos per second that SETI at home is now doing, which does not denigrate this project at all. It's just kind of interesting. And in fact, in 1985, at the conference here, Frank mentioned that now 10 to the 9th osmos were then possible, and he wondered about 2010. And so now we have got that answer. That is a factor of 10 to the 5th over the last 25 years. And I just learned that Frank has repeated this experiment just a few weeks ago on the GBT for the BBC and so forth. I hope that Nova will pick it up, the whole show on SETI and so forth. And it took a half a second. He actually integrated to do one OZMA. He actually integrated for 100 seconds. And so he had 14, the equivalent of 14 OZMAs. The only publication of the results was in an encyclopedia article that he was asked to write, and so he said, well, okay, I'll put it in there. And he said we could have picked up a 1 megawatt transmitter coming out of a 600-foot dish, which was also being built up the road at Sugar Grove at that time by the Navy, if it had been there at 21 centimeters. And now, after OZMA, he gave this talk on the project at Colgate during the interim when the receiver was broke. You'll be hearing an excerpt from that in a second. He wrote an article in Physics Today that was based on that talk. Sebastian von Herner arrived at Green Bank and did an analysis of signals and star density and so forth, and he came to this conclusion, which Frank signed on to, which was a much more realistic and pessimistic conclusion that you're going to have to look at more than 2 stars. You see, it might take extremely expensive instrumentation. It might be 30 years. This is going to lead into the Cyclops project eventually a decade later. And then a year and a half after OZMA was the famous workshop held here. The term SETI, by the way, that doesn't come in until 15 or 20 years later. Extraterrestrial life or communication with extraterrestrial intelligence. With the Nobelist Calvin learning about his Nobel Prize at the meeting, Barney Oliver, Carl Sagan, Morrison, John Lilly. We saw the list of people that came to that meeting, and this, of course, is where the Drake equation was formulated, where we like to booze it up every evening now, in honor of it. So, during that interim, there was a branch meeting of the American Physical Society at Colgate University, just by accident. Frank went up and got added to the program. Bernie Burke was the moderator, just talking about radio astronomy. And I'm going to play you a 2-minute excerpt of the whole thing is recorded. The article in Physics Today was published as a very accurate transcript of the talk, but it doesn't have the Q&A, which is extremely interesting stuff. So if you want to take a look at that. And so here is Frank Drake in April 1960. And first you'll hear Bernie Burke's voice introducing him. And there's a very telling sociological thing here in the first sentence that Frank says when he gets up to the podium.
Mark would like to thank Professor Cohen, and we'll pass on to the next paper, which will be by Dr. Drake of the National Radio Observatory. I don't have the exact title, but it has something to do with Project Ozma. I think I'm here to provide the comic relief to this shindig.
I think I'm here to provide the comic relief to this shindig.
The question as to whether there is intelligent life elsewhere in space has long fascinated people, but has been properly left to the science fiction writers and other non-scientific groups, simply because our technology was not capable of detecting any reasonable manifestation it could be expected from other civilized communities in space. In recent years, however, our astrophysical knowledge of the universe and our technology has advanced to the state where these questions can no longer be ignored by the scientists. I'd like to tell you briefly what the present astrophysical picture of the situation is, followed by some anthropomorphic arguments which help us in our search, and finally a brief description of the technology that one might apply to this problem. The astronomical results of recent years have shown that stars are being formed continuously in our galaxy, and apparently this has been going on since the very beginning of the galaxy, at which time the galaxy consisted almost entirely of pure hydrogen. As the stars have been born, lived out their lives, and died, they have enriched the interstellar medium, the hydrogen, with heavier elements, so that the stars that were born and are being born later in the life of the galaxy.
Many ideas are still very valid. Here's a few quotes from Otto Struve, who had to support this project and was a key person in doing so, and was convinced that not only is this a worthwhile project, but that this was a transition in astronomy. The whole idea of intelligence was modifying the universe such that through radio waves, atomic explosions, various other manifestations, the universe was being modified such that you might be seeing this kind of a signal rather than the standard astrophysical signals that we look at all the time when you do your observations. A drastic and challenging departure from the past. Frank Drake wrote a popular book at this time. I commend it to you to take a look at it, Intelligent Life in Space, a small book. And here are some of the ideas that give you a little bit of idea, thinking of what his motivation was at this time. That we were also stepping into a new era, coming out of our childhood. That we would get useful information from such signals, as well as learn new kinds of beauty and aesthetics and so forth. And that we'll be able to answer some of the most fundamental questions that we have always asked. So the importance of Project Ozma, I've listed what I think are some of them: just doing it, getting other like-minded people involved. One of the top science writers of the time from Saturday Review came out. The president of Notre Dame, Theodore Hesper, who turned out to be very important in later SETI discussions. Barney Oliver, who later became the vice president of Hewlett-Packard, who of course was a SETI leader for decades. The Drake equation, practical issues right from the beginning. You had to combine your SETI with normal radio astronomy. RFI was a huge bugaboo. That you should do SETI in microwaves, narrowband, 21 centimeters. Our society was moving a new light, and it inspired countless scientists. And I just want to end Yeah, I left the quote in my briefcase here. This is from my diary on that day here. The whole afternoon was Dr. Drake from the radio telescope at Green Bank, Virginia, who was very young and eminent, and he was really good at his work and on means of trying to contact other intelligent life in the galaxy. Project Ozma and he are really going at it, and man, he knows his stuff. He's about as sharp a guy as comes along.
Thank you. That was you?
That was me.
That was you. You quote yourself, that's very good. We want to keep on schedule, but let's have time for maybe one or two questions. Is there any, what do you like to?
So, from Travelers, have you read Clark's Traveler 10?
No.
No?
I had that as a notation as soon as I came across that too. Child's in 10 by A.C. Clark. So I have this slide just to share with people along the lines of history. This is the meeting 25 years ago, and on the back of the group photo that you see here in front of the 85-foot, at the top, George Seelstad and Ken Kellerman, who were the organizers, said, "We look forward to inviting you to the 50th anniversary of Project Ozma in 2010. So Ken is here with us. George is not here. And unfortunately, several of the scientists, I'm afraid I don't have the staff people marked here who have passed away, but several of the scientists I've noted here who have died since then in the project.
Hey, thank you. Mike had a comment, but really I have to let him speak.
I have to add a little bit to Woody's final story of our adventures at Texas A&M. In that he's discussing a lecture I gave there and his view of it and interpretation. What isn't said there is that lecture was given at 6:30 in the morning. You might say, what? And you should say, what?
Yes.
And the story there is that the people at Texas A&M had scheduled the important lectures at 2 times, 6:30 and 7:30 in the morning. And why is that? It's because at that time, the Texas legislature had passed a law that it does not get hot in Texas, and therefore they will not fund air conditioning in academic buildings in the state university.